Welcome to this video where we're going to talk about RPC and the request reply pattern in RabbitMQ. RPC, or remote procedure call, is a way that allows two applications to communicate, where we have a client sending a request and then the server or the second application is going to have a function execute something and then return the result to our client. Throughout this video, we'll go over the concept of RPC and the request reply pattern, and we'll see how we can implement them using RabbitMQ. So if you're interested in learning more, make sure to stick around and watch the whole video. If you're familiar with RabbitMQ, you already know that we have a producer, a consumer, we have something called an exchange, and we have queues. If you're not familiar with those terms, I highly recommend you watch my first video, which will explain everything a beginner should know about RabbitMQ. If not, as you can see here in our diagram, we already have two queues here, RPC queue and reply queue. Let's take a look at the first half here first. As you can see, we have the client, which is going to send something to the RPC queue, and then the RPC server is going to get that and consume it. So we can say that the client is going to produce to the queue, and then the RPC server or the second application, the consumer, is going to consume the message. So we can say that the client here is the producer and the RPC server is the consumer. And then let's take a look at the second half. Now, in this case, the RPC server, after having consumed the message and then maybe processed it and got a result for it, is going to play the role of a producer now and then produce the result to a reply queue. And this time the client who produced at first is going to play the role of a consumer and then consume the reply or the response generated from the RPC server on the reply queue. So if you take a look now, we can see that the client produces a message to an RPC queue, which will be consumed by the RPC server that is going to process the message and then generate a result. And then it's going to produce that result to a reply queue, which will be consumed by the client. So we can see here that we have a request reply pattern here. Now here, there are two problems that arise. First of all, let's say we had multiple clients, client A and client B, and then each of those two clients is consuming from a different reply queue. Maybe the first reply queue is called reply queue A, and then client B is consuming from reply queue 2 or reply queue B. Then whenever we're producing to the RPC queue, the RPC server, after consuming that message, should know to which queue it should produce, because in that case, you would have multiple reply queues. This is the first problem. The second problem is we need to be able to match each response to the request, because here whenever the client is producing or sending a request, it needs to know whenever it's consuming from the reply queue that the result that it consumed right now is matched to which request, because it might be sending multiple requests. Thankfully, in RabbitMQ, whenever we're producing a message, we can send some properties with that message, such as the reply to property, which is going to specify which queue the RPC server should produce to. And then we can also pass something called correlation ID, which is like a unique number, which is going to be unique for every request. That way, whenever the RPC server is producing a response back to the reply queue, which will be consumed by the client is going to receive the correlation ID, and then is going to match the correlation ID of the request with the correlation ID of the response, so that it knows which response or which result produced is matched with which request. I want to bring up one more point before we jump into the code. Now, you know, in RabbitMQ we have the exchange, and we usually produce a message to an exchange, and then the exchange, based on its type, is going to route the message to a certain queue. Now, in this case, we still have an exchange, but the work is happening behind the scenes. We will be using the default exchange from RabbitMQ, and it will be of type direct, because whenever we are sending a message to a queue right away without sending it to an exchange in the code, by default, the default exchange, which is of type direct, is going to take the queue name and then use it as a routing key before sending it to the queue itself. This might be confusing, but it will be way more clear whenever we jump into the code. So let's do this right now. I have here a Node.js application, and I'm using TypeScript as a programming language. I have a server running on port 3001, and then I have one endpoint which is doing nothing so far, and we have a config file in which I have some RabbitMQ configurations such as the URL of the local server, and then a queue, which is the name of the queue I want to send or I want to produce to, which is this queue right here, the RPC queue. This is the RPC client. You already know we are working here right now on the RPC client microservice. If you take a look here, you can see that it's producing and it's consuming. So it's playing both the role of a consumer and a producer. Let's go ahead and create a RabbitMQ folder. And then inside of this RabbitMQ folder, I'm going to create 3 files. The first one, which is client, and then I'm going to create producer.ts and consumer.ts. Let's go ahead and export default and create the class. We're going to call it RabbitMQClient. And then let's take a moment and think about what our RabbitMQ client should have as properties. Well, we already said it's a producer and a consumer at the same time, so we can say that we have a producer and a consumer, and of course we need a connection to our RabbitMQ server, and then on that connection we need to create channels so that we can assert queues. And here we can go with 2 channels, one for producing messages, so for sending messages, and another channel dedicated for consuming messages. So based on that, let's say private producer, and we're also going to add the types, but first I'm going to just add the names. We're going to have a consumer, we're going to have a connection, we're also going to have a producer channel and a consumer channel. Now, of course, we need to install the AMQP lib package, and I'm also going to install the types package for TypeScript. Now, once it's done, what we can do is we can, for example, for the connection, add the connection type. As you can see here, this is from the AMQP lib package that we just installed. And of course, here we can also use the channel type, which is as well from this package. And let's do the same here. Now let's go ahead and add an initialize method, and let's think about what we should do in that method. Well, first of all, we need to connect to RabbitMQ, to the server, and then with that connection, we need to create the 2 channels on that connection. A channel is just a virtual connection inside of an actual connection. And just like we said, we're going to have 2 different channels, one for the producer and one for the consumer. And then on those channels, we can assert queues. Now, inside the initialize method, we should assert the reply queue so that we can consume from it. And here, be careful, you might think that we should also assert the RPC queue inside the initialize method of the client. Well, this is possible and we can do that, but this would be useless, because if you assert this RPC queue on the client side, and let's say the RPC server does not exist, then whenever we produce messages to this queue, it's just going to store those messages and they won't be consumed nor processed. So we don't really have to actually assert this RPC queue on the client side. We're just going to do it from the RPC server, and then we're going to be consuming from it. And from the client, we can just send messages to this name. Just like we said, let's go ahead and connect to our server. I'm going to add a try catch block just in case an error happens from RabbitMQ. Console.log error, for example, and then we can print the error just in case something wrong happens. And then here we already have a connection variable property. Let's use it. And here what we can do is we can make use of a connection function from the AMQP lib. This function is going to let us connect to a RabbitMQ server. We have a URL in our config file, which is accessible by rabbitmq.url. So we need to import that package, so let's go ahead and do that. And now what we can do is we can say config.rabbitmq.url. Now we're going to have the connection, which is this object. If we take a look at the interface, we can see that we have a create channel function, which is used to create channels. So let's do that. Here, after having created the connection, let's say this dot producer channel, which is the property that we have here, and let's initialize it. This dot connection dot create channel, just like we said. And let's do the same for the consumer. Now let's go back to our graph. Okay, as we said, we need to assert the reply queue, which is the queue that the client is going to listen to. So let's go ahead and create that queue so that we can start consuming from it. If we take a look at a channel, we can see that we have so many methods here. We can close a channel, we can assert a queue, which is what we need. We can delete a queue. We can do a lot of things like assert, which is creating an exchange, and so on. What we need is the assert queue method. So let's go ahead and use it. Consumer channel dot assert queue. And then here we need to pass in the queue name. Now we don't really care about the queue name. We can keep it empty here. This way, RabbitMQ is going to add a random name. Okay. And then here we can add some options. As you can see here, this is the second property. We can say exclusive true, meaning that whenever this server or whenever the connection to RabbitMQ goes off, this queue, this created queue, is going to be deleted. Now we only care about the queue name, but if we take a look at the queue object that the assert queue method returned, we can see that we have consumer count, message count, and then queue. This property, the queue property, actually specifies the name of the queue that we have here, which is the default name that RabbitMQ is going to create for us. So instead of actually getting the whole object, what we can do is we can just say queue. That way we're just getting that property from it. And here, of course, let's not forget to say await. And I just want to change the name. I want to call it reply queue name. So this is the name of the reply queue that we have just created right now. Now let's go to the consumer file and let's start with our consumer. We're going to create a class as well and we're going to export it. I'm going to call it consumer. And then what do we have? Well, from the consuming side, we need, of course, we need a channel, and which is the channel that we created here in the client, the consumer channel. We need to pass it here. And then we also need the reply queue name to which we're going to be listening to consume messages from. So let's go ahead and do that. Okay, so here I'm going to inject those properties right away in the constructor. So private channel, which is of type channel, which is from the library that we imported. We also have the reply queue name, which is going to be the queue that we're gonna listen to, type string. And also this is the same as just doing this and then inside of the constructor saying this dot channel equal channel. So we can just say private, say the name, and this is going to create those properties for us. So that's a good way of doing it the quick way. Now let's go ahead and create a method called consume messages, and we can add a log here just so we know. We can say ready to consume messages, and then what we can do is we already said that inside of the channel, okay, we used assert queue already, but we can also use something else like send to queue whenever we're producing, publish whenever we're sending to an exchange right away, and we can use consume, and then we pass in the property which is the queue name, and then we have a function here which is going to handle what happens on each message that we receive. So let's go back to our consumer and make use of the consume method. So this dot channel dot consume, and then the name of the queue that we're going to consume from, which is the reply queue, which we already created in our initialize method here. Await this dot consumer channel dot assert queue, and then we are taking the queue name from that object returned. So here we're gonna pass it from the client to the consumer whenever we create it, and then here we can just pass this variable here so we can listen to it, And then here, let's add the function. The message is going to be of type consume message. Okay, this is wrong because we forgot to say this dot. Okay, and then here what we can do is we can just log it for now. We can say console.log. The reply is, and then show the message. Actually, not the message, but the message dot. As you can see, the consume message class or interface has three properties: the content, the fields, and the properties. The content is what we actually need, and we need to parse it, and then message.content, and we need to make sure to say toString. Now back in our client, we can finally initialize this consumer property here. We can say this.consumer equal new consumer, which is the class that we just created right now. We need to pass in the channel, which is going to be this.consumer channel. We also need to pass in the reply queue name, which is this right here. Okay, perfect. Now let's go ahead and create our producer class. Now for the producer, if we take a look at the produce side, we need to pass a few things. For example, just like we said before, we need the reply to property so that the RPC server knows which queue it should send or produce the reply to. So the reply to here is going to have the name of the reply queue, which is this property here, because after asserting this queue, which is the reply queue, we fetched the name, and this is the same name that should be passed here in the reply to property whenever we're producing messages. We also need a channel because, just like we said before, every operation on RabbitMQ should be done on a channel. Just like we saw on a channel, we have multiple methods such as the consume, send to queue, publish to an exchange, and all of that. So we also need the producer channel. Let's go ahead and export default so that we can use it, class producer. And here let's do the same as before, constructor, and then here we need private channel, which is from this class, and then we need the reply queue name, okay, which is of type string, and that's what we need so far. We also need a method to produce messages, so we can say produce messages, for example, and here we're gonna take some data of type any, okay, and then what we can do is this dot channel dot, instead of using consume this time, we're gonna use send to queue. So what we're doing right now is we are sending to a queue, and we need to specify the queue name, which is the RPC queue. Now, if you recall, in our config file, we already added this queue name, but in this code, just like we said previously, we're not actually asserting the RPC queue. We're gonna do the assertion or the creation of that queue on the RPC server side, because it would make no sense to produce to a queue that no one is listening to. It would just be storing messages that won't be consumed if this does not exist. So the creation of the RPC queue is gonna be from the RPC server side. Let's go ahead and import our config file, and then here what we can do is say config.rabbitmq.queues.rpcqueue, because in send to queue we need to specify first of all the queue name and then the content. I don't know why this is happening, but this is what we need to specify. So here what we can do is say buffer.from, because we need to send it as buffer, and then I'm assuming that what we have is JSON, okay, so in that case we need to send it as a string, so json.stringify, and then the data that we got here in our method. Now other than that, we can pass in a third argument, just like you can see here, which is options. Now what do we need to send? If you recall, we said we need to send a reply to, so that the RPC server knows which queue to reply to, and a correlation ID, so that we can match every response or reply to every request. Because we don't want to be consuming messages here in the consumer without actually knowing this message or this reply belong to which request. So here we can check what we have. We have so many properties, but what we need is we need a reply to, okay, and the reply to is going to be the reply queue name that we passed. We should say this because it's a property of the producer class, and we also need a correlation ID. Now we can make use of UUID. We can use random UUID. You should make sure that you're importing it from crypto. Okay. Now I'm gonna set it in a variable here. Inside of this, I'm gonna say UUID, for example, equal this, and then I'm gonna pass in this created variable as a correlation ID, and here we can say, for example, the correlation ID is UUID. So this is what's gonna be used to produce messages to the RPC queue, and the consumer is actually this part here where we're consuming from the reply queue. And just so that you remember, all of this is happening in the client service. We are still in the client service. We're consuming from the reply queue and we're producing to the RPC queue. But of course, you don't have to have multiple files, but I think this architecture is pretty nice, so I like to keep it clean. Now, just like in our initialize method in the client, in the RabbitMQClient class, just like we initialize the consumer, we're gonna do the same for the producer. So let's say new producer this dot producer channel, and then we need to pass in the second property to the constructor, which is reply queue name. Now what we also need to do in our initialize method is we need to start the consumer. So this dot consumer dot, we need to call this method here, which is consume messages on the consumer. So let's do that. All right. Now, if you realize, whenever I said consumer dot, we didn't get the method name, and that's because we didn't specify the types here. So let's go ahead and do that. So this is the consumer that we just created now. And for the producer, let's give it the producer type that we also just created now, which is this. Now, if we check dot, as you can see, we got the methods that we have. So this way now, we are actually running the consumer from the client, from the RabbitMQ client in our initialize method. We can also add one more thing, which is a method called produce, which takes data. That way, whenever in our application, we are going to need to produce messages to the queue, instead of actually having to access the producer itself, we can just do it through the client. So the client can expose the produce function here, and all it does is return this dot produce, this dot producer, and then dot produce messages, and then we send the data itself. And just like we've seen before, inside of the produce messages, on top of actually sending the data content that we're gonna be getting from the produce method from the client this time, we're also gonna be adding the reply to property and the correlation ID. Now, small note that in this application, I'm actually generating the random correlation ID inside the produce messages, but let's say that your requests already have a correlation ID field from the headers, so you could access that from rec.headers.correlation ID, for example. Then instead of actually creating it inside the produce message, you would have something like this, for example, type string, and then you would pass it from your controller, but I'm just gonna keep it this way in this project. Now, if we open the RabbitMQ management, we can see that so far we have 0 connections, we have 0 channels. Those are the default exchanges, and we don't have any queue. Now, if you take a look at our initialize, we are creating a connection, we are creating 2 channels, and then we are creating 1 queue, which is the reply queue to consume from. Now, of course, all of this isn't created yet because we have not called our initialize method, so let's do that in our server. Now, of course, we need to import that class to server.ts, and we need to create an instance of that class, so const RabbitClient, and now inside of server.listen, for example, as soon as the server is running, we can say RabbitClient.initialize. I'm gonna run the server and let's see what happens. Server running and ready to consume messages. Now, if you go back to our initialize, okay, we created the connection, the 2 channels, the assert queue, and then remember, we are, after creating the consumer and the producer, we're actually running the consume messages method inside of the consumer, in which we have the log ready to consume messages. Now, if you go back to the management here, we can see that we have a queue, and this is the name. Like we said, this is the reply queue, and the name is generated by default because we didn't pass in a specific name. If you take a look at our channels, we have two channels, just like we said, a producer channel and a consumer channel. If you take a look at connections, we also have one connection from our client here. So this is perfect. Alright, now let's test this API. Now what I added is I'm logging whatever body we're getting from the request, and then I'm calling RabbitMQClient, and then I'm calling the function, the method called produce, that we exposed so that we can use to produce messages, okay, to the RPC queue that does not exist yet. We're just using the name, but it does not exist yet. So let's see what happens. This is Postman here. I'm calling this route. Now, the idea of the application is you send a specific operation, multiply, divide, sum, whatever, and then you send two numbers, and then the RPC server is going to calculate the result and send it to you. Obviously, so far we don't have an RPC server nor an RPC queue. We're going to add them right now. But first, if we hit send, let's see what happens. If we take a look here in our logs, we can see that we are actually printing the message, which is from the server here. This is the body, okay? And then we're also printing a correlation ID, which is the unique number that we said here we're sending in our request with our message as a property, which we are creating inside of our producer. So now we know that we're actually reaching this, we are actually sending a message. And to make sure that the message is sent, I'm gonna send again, refresh. Okay, as you can see now, we can see that there's a message here. So we can detect that message inside of RabbitMQ. Now there are a few problems in our code, and to show that, I created two different services, service1.ts and service2. Both have the same code, a function, a function called sendMessage, which is going to be using the RabbitMQClient class that we have to produce messages. And this makes sense. In an application, you're not going to have all of your code or all of your APIs inside of your server.ts. You're going to have controllers, you're going to have multiple modules maybe, and every controller is going to call its own service, for example, service 1, service 2. And then if you need to use the RabbitMQClient to send messages from multiple places inside of your application, it would make sense to use the same instance of that RabbitMQClient. The way it's done now is we're actually creating new instances every time. And there's a problem before that as well, that right now, if I try to produce a message with this new instance here, the new RabbitMQClient instance inside of service 1 or service 2, if I go ahead and on Postman hit send, as you can see, we received an error saying cannot read property of undefined reading produce messages. If you go to produce, here it's telling us that it cannot read produce messages of undefined, meaning the producer is undefined. And this makes sense because inside of service 1 and service 2, we created a new instance of RabbitMQClient, but those fields, producer, consumer, connection, are not initialized. They're only being initialized inside of Initialize, which is happening inside of the server here, but on this instance only. So we're dealing with three different instances here, one for every controller or service that we have in our application. Now, to fix the produce error here, the undefined error here, what we can do is, inside of our client, make sure that if not connection, for example, not this dot connection, meaning that if this connection was not initialized, then we know we didn't call the initialize method. So what we can do is say, await this dot initialize, for example. And then after this is done, we can return a message. This is going to help us get rid of this undefined error. So now if we send, as you can see, we send the message. Now it was sent 3 times because in our server we're actually sending it 3 times. Once from the client instance here, once from the service 1, service 2. This is just to simulate that you might be using the client, RabbitMQClient, from different places throughout your app. Now you might think that there's no errors here, but if we take a look at our client, every single time we initialize, we are actually creating a new connection, 2 new channels, and a new queue. And to make sure of that, if you go back to our RabbitMQClient, we have 3 different connections now, and we have 6 channels. and we have 3 different queues, and that's not what we want. And this is happening because we're using 3 different instances of the RabbitMQ client. Instead, we should make it a singleton. Now, to turn the RabbitMQ client into a singleton, we need a few things. First of all, we need to make the constructor as private so that we cannot create instances of that class anymore. Secondly, we need to create a private static property, we can call it instance, which is going to return a RabbitMQ client. So this is the only instance that we're going to be using. And of course, we need to be able to actually show this instance to other files in our project. So what we can do is we can create a public function. Now by default it is public, so you don't really have to say public, but I'm just going to say it so that you know that it should be public. And of course it should be static here. We don't have to make it async here. We can call it get instance, and then what we do is we check if not this.instance, meaning we don't already have an instance of the RabbitMQ client created, then we need to create it. So this.instance equal new RabbitMQ client, okay? And then we just need to return it. So now any service in our application that needs to access the RabbitMQ client to send or to produce a message is going to get that instance from the public static function getInstance, which is going to check if you already have an instance and return it. If not, it's going to create it and then return it. Now, to be able to know if we already have a connection initialize, or if you already called the initialize method before producing, we can do it in a clean way and create a private property here and call it is initialized and set it to false by default, okay? And then after initializing here inside of our initialize method, what we can do is, just to make sure we can't initialize it more than one time, we can say if this.initialized, so if we already have this to be true, so we already initialized RabbitMQ, we can just return, so we don't create a new connection, new channels, and waste resources. And then inside of this function, once we're done, we can say this dot is initialized true. So now we know that RabbitMQ has been initialized, and now this class is a singleton. We can't create instances anymore because the constructor is private. To be able to get the single instance, we call a getInstance function static, which is going to make sure we only have one instance. And then inside of produce, we can just say if not this.is initialized. So we know that we are trying to call the produce function on a client that has not been initialized yet. Maybe we made a certain mistake in our code. So just to be safe, you can say await this.initialize. So in case we try to produce and the RabbitMQ client is not initialized, we're going to call it and then we're going to produce. Now what we can also do, instead of exporting this the way it is, we can say export default RabbitMQ client dot get instance. This way, whenever we import this class, we're actually also calling this function to get the instance right away. If it does not exist, it's going to create it and return it, else it's going to return it. Let's make sure that it is working. Let's take a look here. We don't have connections, we don't have channels, we don't have queues, and that's because the queues are exclusive. So we set it to true so that it got deleted whenever we stopped the server from running. Let's go back to our server now, and instead of doing this, now we can do RabbitMQ.initialize right away, because this is the instance. Remember, we are importing the instance now, the single instance. So whenever we need to produce, we can just do this RabbitClient.produce, and then here RabbitClient.initialize, and then inside of our services as well, instead of creating a new instance, we're going to use the singleton, and here as well we're going to use the singleton. All right, let's rerun the server, and now we're still sending from three different places, but this time let's open Postman, hit send. As you can see, we didn't get an error. Okay, perfect. And if you open the management studio again, we only have one connection. That's it, one connection, 2 channels only, and only one queue has been created. Unlike previously, whenever we used instances, so from different places, we created different connections and then different queues and so on. This way now, we made it a singleton and we can only use one single instance throughout our application. Now inside the consumer, I forgot to add one more property, which is the options here. And we can call this noAC. And if we set it to true, whenever we receive a message, we're going to send an acknowledgement saying that this message has been consumed correctly so that it can be safely removed from the queue. So far, this is what we worked on. We made the client, we made a produce function, we are sending the reply to and the correlation ID, we created a consumer, we are consuming from the reply queue, and now we need to work on the RPC server. We need to create or assert the RPC queue. We need to make sure that the RPC server is consuming from it, and we need to create a produce message, which is going to send a message with a correlation ID, which is going to be the result of whatever the client is trying to get here. I went ahead and created a duplicate project from our previous RPC client project, but this time I called it RPC server, and we are going to make the changes on our RabbitMQ client. So now we're going to be working on this part right here. Alright, the first changes that we need to do is inside of our consumer, for example. This time we're going to be consuming from the RPC queue and not the reply queue. So we can just call this RPC queue, or we just can call it queue, whatever. Okay. And then here, for example, whenever we receive a message, we need to make sure that the message contains some fields, such as the correlation ID and the reply to. Why? Because if we don't have a reply to, if we don't have this field, reply to, then whenever we process or consume that message, we're not going to be able to know where to send it or to which queue to send it. So let's go ahead and get those, deconstruct the object and receive the correlation ID and reply to from message.properties. And this is short for saying message.properties.correlation ID and setting it in a variable alone, and then so this is just a quicker way to do it in JavaScript. And then what we can do is we can say if not correlation ID or not reply to, then we can throw an error or do anything here. I'm just gonna say console.log missing. If not, what we need to do is await, and then here we need to do something. We need to call a specific function on the RPC server so that we can process the message that we received and then send it back to a queue. But before handling that, let's go to our producer and make the changes as well. Here we don't need to create a correlation ID because we're going to be sending the correlation ID that we already get, which is going to be the correlation ID that we sent here from the client. So we're no longer creating it here, we're instead getting it here. So correlation ID, which is of type string, we can replace this. And then here we no longer need a reply to, because before, like we said, we need to specify the reply to queue name so that the server knows where to send the message. So now when we're sending the message and we're consuming it here, the client does not care about the reply to property because it's not going to reply back to the server, so we don't really need it. So I removed it. And we also need to make one more change. Instead of actually sending the message to the RPC queue, which is this one, so we don't need to send it back here, it makes no sense. We need to send it to the reply to queue, which is the reply queue here. So if you go back to our producer, here we no longer need this. And it should be dynamic. So whenever we create a new instance of the producer, we don't know what reply queue we are actually sending it to, because like we said previously, we might have 20 clients and every one of those 20 clients listening to a different reply queue. So the RPC server would need to produce different queues, not only one queue. So we shouldn't put it in the constructor. Instead, we should put it dynamically in this function here, reply to queue, which is of type string. And this is the queue that we're going to send the message to, or the response to. So now this is our updated producer. We can remove the unused packages. And this is again in our RPC server. We're working here now inside of the red marker. Okay. Now let's make the changes needed in our client. First of all, our producer no longer takes a reply queue. If you take a look, it only takes a channel. Our consumer still takes a channel, but this time we're not consuming from the reply queue, we're consuming from the RPC queue. So here we need to assert that queue first of all, which is this queue. We don't need RabbitMQ to create the name for us. We can set our own custom name, which we already have here in the config file. So we can say config.rabbitmq.queues.rpcqueue. Again, here we're just fetching the queue property from this, which is the name, and I'm changing the name to a custom variable name, which is reply queue name. Here we don't need it to be this, we can call it RPC queue, and then we pass it down there. And here we also need to make one more change. If you recall, inside of our producer, now we're getting the correlation ID and the reply to queue inside of our produced message dynamically, because we already got those from the client. Whenever we consumed those, we got those attributes. So in our client, we need to pass those data, correlation ID and a reply to queue. And of course, we need to add those as parameters for our produce method. And those are of type string. Now that we have made the changes, let's go back to our process. What's happening here to the cycle? Our client is already done. We are producing a message to the RPC queue that we just asserted in the RPC server. We updated our consumer so that it consumes messages from the RPC queue. We also added the producer message, which is produce, which sends to a specific queue and with a specific correlation ID. But we still need to add the function or to handle the consumed messages. So we need a message handler, because here, whenever we're consuming, we need to call a message handler to which we will pass the message, so that creates a result, and then call the producer to send that result back to our client so that the cycle is fully working. Let's go ahead and create a new file in our source folder. I'm gonna call it MessageHandler, okay, of type TS, and then here I'm gonna create a class, and let's export it as well. I'm gonna call it MessageHandler, and then inside of this class I only have one method, which is static, which will be handling our messages. And then we need, let's say, operation, because if you remember, we are sending an operation in our body, and this is just project specific. This isn't something related to RPC in general. So I just need to know what operation I'm trying to do. And then we can also have another property. The operation is of type string. We can also have another property, which is the data, so the content of the message. We are also going to have the correlation ID, which is of type string, and then the reply to, which is the queue, which is also of type string. And let's see why we need them. So here what we need to do is, let's just create an empty response object first, because again, we are in the RPC server, so we need to create a result or a response so that we can turn it back to the client. So here what we can do is, of course, we already know that our rec.body, the data being sent, is num1 and num2, so we are expecting this. Of course, you can make it cleaner by creating DTOs so that you know what to expect, but I'm just gonna do it this way so that the video is shorter. And then we can say, just to make sure everything is fine, we can say the operation is, and then print the operation. Okay, and then we can create a switch case, for example, on the operation field, and then let's check what operation we have. Let's just assume we have two cases, which is multiply, and in that case the response would be num1 times num2, we're just multiplying it, and then we can add a break. And then the second case, which is, for example, sum, let's say, We can also add a default case. We can say, for example, response equals 0 or whatever based on your application needs. And after doing that, we need to produce the response back to the client, which is the RPC client in our case, which is this right here. Let's do await rabbit client dot produce. Of course, our rabbit client should be imported, and this is the client, which is a singleton, just like we've seen previously. We're actually exporting the instance, the single instance that we have. So here what we can do is say rabbit client dot produce, and then we need to pass in 3 arguments: the data, which is the response, the correlation ID, and then the reply to queue. Just like we said previously, the correlation ID is the one we consumed here, which is sent from the client, so we can match the response here that we're sending to the request being sent from the client, and then the reply to is needed, so we know the server knows where to reply. I know I'm repeating myself multiple times, but it's just to help you understand better, just in case you're confused. And we need to send the correlation ID first. That way we're actually handling the messages that we receive from the client, and then we're producing a response back using our single RabbitMQClient instance. Now we still need to do some work here in our consumer in the RPC server. Like we said, we need to handle the messages in the consumer. So whenever we consume a message, after making sure it includes a correlation ID and a reply to, and of course here we said we could throw an error or do something else, I'm just gonna log it. And then here, in case everything is fine, no errors, we can call the MessageHandler, which is the class that we just created. And since we have a static method, we can call it this way, which is .handle, and we need to pass in those stuff. Now, operation, how do we get that? We could say message.content.operation, or we could send it in a header, which is a good way, I think. What we could do is we could add it in a header, for example, under a function property. I think it would be a better way of doing it. But of course, you can set it in the content. So what I'm gonna do is, here I'm gonna say const operation equal message.properties dot, here we have a headers, and then we can, let's say, function. And this function would be a custom field that we add to the headers in the client itself. That way, what we can do is, the operation could be sent that way, and then the data is, of course, we need to parse it first. It's stringified, but it's of type JSON, so we need to say JSON.parse, and then we take the content that we get. And here we also need to send the correlation ID and the reply to. Of course, it's whining here because we need to make this async. Alright. So now what we're doing is, whenever we consume a message, we're gonna process the result by calling the message handler, by passing the operation and the data. And then here, based on the switch case, we're gonna know which response is the correct one and then send it. Also, keep in mind, we could have added a try-catch block, or inside of default, if we don't get any correct case, we could create another function here, another method called handle errors, for example, which would also produce a message, but this time the message produced would, for example, be of this form, for example, error true, and so on. That way, whenever the client is consuming back a response, it can check if the error flag is set to true, then it would throw or return a response of error. But we're not gonna go into that in this video. By the way, now inside of the server here, we don't really need Express because we're not getting HTTP requests or anything. So we can remove that. And then here we could say RabbitClient.initialize, and that's everything that's happening. Now, if we hit save and rerun the server, we should get a new connection as well if we refresh. Actually, it is correct, because if we check the queue, we have a queue called RPC queue, but I'm not running my client. So let's go ahead and run the client as well. Alright, now that the client is running as well, if we go back to our management here, we can see that we have two connections, one from the client and one from the RPC server. We have 4 channels, because as we said, one for producing, one for consuming, and we have a client and a server, so both of them, 2 + 2 is 4 channels. and we have two different queues, the RPC queue, which is this one, and then the default name auto-generated queue from RabbitMQ for us, which is the reply queue here. This is perfect. This is just like we needed. Back in our RPC client, inside of our producer, here in send to queue, we're gonna add some options other than reply to and correlation ID. We're gonna add the headers just like we said, and then we're gonna add a function property, and then like we said, we're gonna take data.operation, and here the data that we're receiving from the produce messages and from the produce is the request.body. So from our request here, which is this operation, of course we didn't need to do it, just like I said previously. It could have been taken from the content of the message itself, but it's a best practice to send it. If we have different functions on our RPC server, it would be best to actually separate it and put it in the headers, for example, like some extra piece of data that we need. So I'm just doing it for better practices. Now back in the RPC server, I added a log inside of our consume message just to check what message we're receiving. And now in Postman, I'm gonna hit send, and if you go back here, as you can see, we have consumed a message successfully. Consumed operation multiply num1, which is 2, and num3, which is 3. However, the operation is undefined, so let's check why it's undefined. There's a chance that I forgot to actually save the RPC client, because now whenever I send a request, as we can see in our RPC server, we're actually getting the actual operation name. Now let's go to the produce message and see what the result or what the reply is going to be. We can say responding with, and then data. So in the message handler, whenever we're getting the response after doing the calculations based on the operation, we're calling produce. We're here now, and then we're logging what response we're gonna send. Let's open Postman, send. If we check here, responding with 6, and this makes sense because the operation is multiply, and then we have 2 times 3, so we got 6 from our RPC server. And if you go to the client, as you can see, we got the reply is 6, and this is inside of our consumer now. Now there is one crucial thing missing here. So inside of our RPC client, whenever we're producing a message here, whenever we're sending to a queue to produce, we need to wait for a response. So here we need to wait for the response so that we can send it to the client. How do we do that? Well, we need to find a way so that the consume message here notifies the produce message here that a response has been sent. Also keep in mind that we should keep track of the correlation ID so that we know which response that we consume here on the reply queue belong to which request that we initially sent to the RPC server to be processed. To do that, we can use event emitters. So in our client, for example, we can add a new field. Let's call it event emitter, which is of type event emitter, and we can get that from events. And then inside of our consumer, we need to add this new property. So event emitter, which is of type event emitter, is from events. And then here we need to emit an event as soon as we consume a message. So now here, instead of just logging it, we're actually gonna say this dot event emitter dot, and we can see that we have emit. Now, what is the event name? If we take a look here, the only event name that makes sense is the correlation ID because it is unique. So now how do we get that correlation ID? Well, whenever we're consuming the message, here we said that the RPC server is going to reply, it's going to respond, but it's also going to send a correlation ID. So, and like we've seen before, we can say message dot properties dot correlation ID. So this correlation ID, that we are consuming here comes from the response that the RPC server produced. But initially, it's the one we produced here initially in the client whenever we produced or sent a request. So now you can see how it's all coming together. Okay, let's make sure it's string. And then we also need to send any arguments that we have. We're gonna send the message, which is actually the response here. Now inside of our producer, we also need to add the event emitter. So let's do that. All right. And now here inside wait for the response, what we're gonna do is we need to listen or to subscribe to a certain event name. So we can say this dot event emitter dot, we can say once to listen to it once, because it's gonna have one response only on a certain correlation ID. If for any reason more than one has been sent, we only should listen to one. So here we can say the correlation ID is the UUID. So here we listen to that. Okay, and then what needs to happen is whenever we get that event, the message or the data that we receive, we can call it data, we need to log it now, just for now, just to make sure that it's working. JSON.parse message.content.toString, and here we called it data, not message. Okay, so let's do that and let's save it for now. So now what's happening, but before we need to fix this, because now the producer and consumer take one more parameter in their constructor, which is the event emitter. And we also need to make sure that we are initializing this event emitter, because here we're just creating it, but we haven't initialized it with a value or anything. So let's come here and say this dot event emitter equal new event emitter. Okay. And now if we save, what we're doing is we're actually consuming the replies, the responses from the RPC server, and then we are emitting an event on, and the event name is the actual correlation ID, the initial correlation ID that we have created when we produced the request. And then the producer is going to subscribe and listen to that UUID, to that correlation ID that we have produced here. And once an event is emitted onto that event name, we are going to get the data and then show it here on the screen. So let's check if it's working. I'm gonna open Postman, hit send, and as you can see, we got the reply is 6. This is in our RPC client. So we consumed it here, and then inside of the producer, we logged 6, as you can see. So there's only one more thing that we should do. If we take a look at where we're calling produce messages from, it's the produce method inside of our client, and we're returning the value. But here inside of event, if we try to say return, and we try to return this, okay, you might think this is the correct way of doing it, but if we try this and we go back to Postman and hit send, as you can see, still nothing. But first we need to make sure that we're saving this in a variable. So I'm gonna say const response equal this, and then I'm gonna say res.send response. Right, now if we save and then we hit send, as you can see, we got nothing. And if we try to return this as well, which you might think might solve it, if we try to say send, now our response is just an event. So we need to find a way to return the actual value, which is 6. Well, to solve this in an easy way, what we can do is we can wrap this event emitter inside of a promise. So we can say return new promise, then resolve reject, and then here we can add this code, this.eventEmitter.once, and then whenever we get a reply, I'm gonna store it inside of reply, for example. We can say resolve reply, right? And this is the reply that we're getting here from the reply queue from the RPC server. Just making sure that you're sticking with me. And now if we save and open Postman and hit send, as you can see, we got response 6. So we actually sent the request here, multiply num23 to the RPC queue, we produce to it, and then the RPC server is consuming from it, then producing the reply back with the correlation ID to our reply queue. We consumed it, created an event on the correlation ID as an event name, and then we got our response back. As you can see, this is the request reply pattern in action. We can try this with some, for example. We should get 5. If we hit send, indeed we got 5. Our RPC server is running and working. And like I said previously, you can also, inside of your RPC server, produce an error, an object with an error flag saying error true, just in case some error happened and you need to be notified here, so that you can return an error to the client here, to the client making the API call. And that way, for example here, you could have checked this by saying if, after the reply, if, for example, reply.error, if it is true, then, for example, you could throw an error or handle it or whatever. I'm not gonna do it in this video because this video is already huge, but you get the main idea of request reply pattern. Now, one useful thing you can do as well inside of the produce messages, inside the options, whenever you're producing a message, you can also add an expiration for your message. For example, you could say 10, and this is a number. For example, this would mean 10 seconds. So the message would expire after 10 seconds. It would no longer stay on the queue, because let's say you sent a message and the RPC server was down. So the client on Postman or any other client is waiting for a response. Let's say we have a timeout mechanism that after 15 seconds, the response would return timeout. We need to make sure that the message is deleted from the queue because we don't really need it anymore. So here, for example, we could say 10, and this would be our timeout, for example. And then we would need one more thing here. Here we also need to make sure that we have a timeout function, so that, let's say, if after 10 seconds we didn't get an event with the response here, we could also throw a timeout error for the client. Now, I'm not gonna add a timeout functionality in this because this video is already too long. I have a separate video on how to use promise.trace to create timeouts if you have multiple promises. So you would basically use this promise, you would put it in a variable, and then run it against another promise, which is timeout, basically. And then I'd say just watch my video if you wanna implement timeout. I'm gonna leave links in the description. Also, if you wanna watch how you can use exchange of type direct in RabbitMQ with microservices in Node.js as well, I also have a video on that, so I'm gonna keep it in the description. I hope it's become clear how this flow works. If you have any questions, leave them down in the comment section. Please, if this video was helpful, leave a like and subscribe. Thank you for watching, and I'll see you next time.